All right, so this is 2000 question four, and this is going to be a two sample T type problem. Um, so baby walkers are seats hanging from frames that allow babies to sit upright with their legs dangling and feet touching the floor. Walkers have wheels on their legs that allow the infant to propel the walker around the house long before he or she can walk or even crawl. Typically, babies use walkers between the ages of 4 months and 11 months because most walkers have tray tables in front that block babies' view of their feet. Child psychologists have begun to question whether walkers affect infants' cognitive development. One study compared mental skills of a random sample of those who used walkers with a random sample of those who never used walkers. So we have two random samples. Mental scores were average 113 for the 54 who used the walkers with a standard deviation of 12, and 123 for the 55 who did not use the walkers with a standard deviation of 15. So the question is there evidence that the mean mental score of babies who use walkers is different from the mean mental score of babies who do not? So essentially we have a mental score, average score of 113 here, and a mental average score of 123. And we can see that those who don't use the walkers have a higher score. But the question is it statistically significant? So, oh, and by the way, they use the word difference, and difference tells us we're working with a not equal situation. So, a mean mental score with babies using walkers is equal to that of not using walkers. Babies with walkers is not equal to those who don't use walkers. Again, we have to define our parameters. The true population mean mental skill for a baby using a walker, and true population mean mental score for babies not using a walker. Both samples are random. Both are random samples. That's given, so we're good with that. The two samples are independent. It's reasonable to assume that the mental score of babies in walkers did not influence those who are not in walkers, and vice versa. N is less than 10% of the population. It's reasonable to assume that more than 540 babies use walkers. It's reasonable to assume that more than 550 don't use walkers. So N is less than 10% of the population for both. All right. Both N1 and N2 are greater than 30, and probably should have said the sample sizes. So 54 and 55 are greater than 30. Because both samples are sufficiently large, the distribution of the means is approximately normal. Please make sure you're saying the distribution of the means when you're talking about that. Got to name the test. They've gotten really picky about that. In this case, we have two means, so it's two sample. And since we're using the standard deviation from the sample, it has to be a t-test. So two sample t-test. If you write two sample t-test, you're probably good. Probably don't have to add difference of means. So stat test, drop down to two sample. Oops, I went way too far. Two sample t-test. And I have a mean of 113, the standard deviation of 12, the sample size of 54, a mean of 123, the smart kids that didn't use the walker, 15, and a standard deviation of 55. And we wanted to use a not equal. We never pool. And we end up with a pretty small t statistic. And a p-value of 0.02. With the p-value of 0.02, we're going to reject the null. So our p-value is 0.002. We reject the null. There's plenty of evidence, whole lots of it, to say that the true population mean for mental score of babies and walkers is different than the mental score of babies who do not use walkers. We don't want to say that it's less than, because that's not what we tested. Even though it is, we don't want to say it's less than. We just want to say it's different. So the suppose that a study using the design found statistically significant result. It did. Would it be reasonable to conclude that using a walker could change mental skill? Well, although the result is significant and it's correlated, this was an observational study and not an experiment because treatments were not assigned. Because it was not an experiment, no causal relationship can be concluded. Sorry, the kid just might be stupid after all.